All right, we are reviewing our unit on complex numbers, simplifying radicals, negatives within radicals, all that good stuff. So let's go ahead and just look at numbers 1 and 2. It's asking us to simplify the following radicals. Okay, now we know how to simplify radicals. We're basically, if it's not a perfect square, we're trying to pick out pairs or whatever groups of numbers it's indicating. These are square roots, hence there's going to be an invisible little 2 there, and that's why we take out pairs. That's why we have to have two numbers that are exactly the same. Okay, well, we learned in this unit that this I inside our radical automatically, kind of spoke ahead of myself. This negative inside of this radical, this negative 99x cubed, this we pull out and we turn it into I on the outside of our radical. Okay, so now we have I with the square root of 99x cubed. Okay, now we can start breaking down 99. Okay, well, I know I can divide 99 by 9 and 11. Don't have a pair yet, so I can do 3 times 3, and 11 is prime, so that I know I can take out the 3. This is going to turn into 3 and the I that was able to come out. Okay, the 11 had to stay in, and I'm going to leave a little space just in case our variables, which we deal with next, can pair up and leave the radical as well. Okay, so now we look at our variables. We have x cubed, or in other words, x times x times x. Okay, well, we know that there's an odd number, so we can take two of these guys. They create one pair of x's, and one x is left inside. So our final answer, 3ix square root 11x. And another way we could write this is 3xi. I kind of acts like just another variable here. Excuse me. Okay, let's look at number 2. So we see that we have a coefficient in front, and we're not going to deal with that until the very end. But we see that there's a negative. Okay, so we automatically pull that negative out, and that turns into our I. And I write my I's different ways each time, I swear. Okay, but then we can start breaking down 124. Okay, well, 124, I know it's even, but let's see if I can break it down by anything else. I'm just going to see 124 divided by 4. Let's go 4 times 31. Okay, and then 4, I know I can break down to 2 and 2, and 31, I cannot divide by anything. That's actually a prime number. Okay, so we have our 2's that were able to come out. They create one pair. So we have our I that was able to leave, multiplied by the 3 that was already out, and multiplied by the 2 that we were able to take out of the radical. Okay, and again, our 31 had to stay inside. And now let's deal with our variables, see if anything else can leave the radical. Okay, so I have x squared, or in other words, x times x. Well, that's an even number, okay, 2 of them, and they can create one pair of x's. Okay, well, now let's look at our y's. We have y to the 5th, or y times y times y times y times y, 5 times. Okay, so we know it's an odd number, so 5 is small enough that you can just write it all out, okay, but we'll get to where we are going to subtract. But you could take 2 pairs of y's, one y has to stay in, so hence y squared for my 2 pairs of y's, and one y that had to stay in. Okay, so let's go ahead and simplify this answer. Okay, I'm going to multiply my numbers first, so 3 times 2, that's going to give me 6. And then I'm going to do my variables next, so x, y squared. Okay, then I'm going to write my I, root 31y. And there is my final answer. Beautiful. Alrighty. Okay, so now for numbers 3 through 8, it's asking us to simplify, and you're going to see addition signs and subtraction signs in between. Okay, so we're simply asked to simplify these guys. Okay, when we see this addition sign, think that this is just an addition sign that's being distributed to whatever's after it. Okay, so whatever comes in front can stay the same. 3 minus 5i. Okay, positive 1 times 5 is just positive 5. 1 times negative 4i is negative 4i. Okay, so we can go ahead and simplify this by combining like terms. We're not multiplying anything here, we're simply combining like terms. So I can combine my i's together to get negative 5i minus 4 more I is negative 9i. Okay, and then we can combine our constants. I have 3 plus 5 would give me plus 8. Now the technical way to write these complex numbers, meaning a real number followed by an imaginary number, would be the real number comes first. So our final answer here would be 8 minus 9i. And there we go. Okay, so the one with the imaginary number actually comes second. Okay, number 4. Again, we have an addition sign in the middle, so that just distributes. All it's saying is it's going to keep these signs the same. The negative and the positive will stay the same. The guys in front stay the same anyway, so negative 4 minus 6i minus 7 plus 2i. Okay, now we can combine like terms. Let's go ahead and just do our constants first since they come first. So I have negative 4 minus 7 more, and I'm going to get negative 11. Okay, then I can combine my imaginary numbers. Negative 6i plus 2i. It's going to give me negative 4i. So our final answer, negative 11 minus 4i. Written in correct descending order, so we're good there. Okay, number 5, again, we have an addition sign that's being distributed. It keeps those signs after it the same. So we have 5 minus 2i minus 6 plus 4i. Okay, let's go ahead and combine like terms. We can do our constants first. So I have 5 minus 6. 5 take away 6 is going to give me negative 1. Then I can combine my i's. Negative 2i plus 4i is going to give me positive 2i, which is my final answer. Negative 1 plus 2i. Now, would it be incorrect to write 2i minus 1? No, it wouldn't. We just like to write it in that order that it usually comes in, or that's technically more correct. Okay. Let's look number 6. So these guys look a little weird. We have 2 parentheses here, and all we have, this negative that comes before this 3i, that simply turns that into a negative 3i. So this guy stays the same, so we have negative 7i in front. That turns into negative 3i, and then the addition sign keeps those signs the same, so then plus 8 plus 3i. And now I can just simplify by combining like terms. So let's do our constants first. And I actually only have one constant, and it's 8. So we have 8, and that doesn't change. And then we have our imaginary numbers. Negative 7 minus 3i plus 3i. Okay, well I know minus 3 and plus 3, they cancel each other out. That's just going to turn into a 0. Okay, and then 0 minus 7i would just be negative 7i. Final answer, 8 minus 7i. Beautiful. Okay, number 7. Now we have a subtraction sign in the middle. Okay, and what this does, it's technically saying negative 1 times positive 6, and negative 1 times negative 7i. Okay, well, when we multiply a negative times a positive, changes to a negative. Negative times a negative changes to a positive. That's why those signs after it changes. Again, these guys stay the same. So we have negative 8 plus I minus 6 and plus 7i, because those signs now changed. Okay, combine like terms. We have our constants, negative 8 minus 6 more is going to give me negative 14. Then I have positive 1i plus 7i. 1i plus 7i is going to give me positive 8i. And there's my final answer. Okay. And number 8. Okay, again, we see that subtraction sign in the middle. It's going to change those signs because a negative times a negative in both cases changes to a positive. Okay, these guys stay the same, however. Negative 7 minus 6i. Negative 1 times negative 2 is positive 2. Negative 1 times negative 1i, positive 1i. Now I can go ahead and combine like terms. So I have negative 7 plus 2 is going to give me negative 5. And negative 6i plus 1i is negative 5i. And there's our final answer. Okay, so those guys we were simplifying by adding or subtracting. 9 through 12, we are going to simplify using FOIL or the box method, where basically here we are now multiplying. Okay, and when we are multiplying, we need to remember one key rule. Okay, we're going to most likely get an I squared when multiplying these guys together. Well, whenever we get an I squared, I times I squared, this guy turns into a negative 1. So that's that important rule we need to remember. Okay? Alrighty, so let's look at number 9. So technically I don't have two binomials here. I actually have 3 sets of parentheses. Well, it doesn't matter which order you go in with multiplication, but I'm just going to multiply the first two first. Okay, so I'm going to take, we're actually not even using the FOIL or the box method here. We're just distributing. Okay, so I'm going to take negative I times negative 4i. Okay, and that's going to give me negative times a negative, positive 4i squared. Okay, and you might see this I squared here and want to change it right away. You can do that. I'm going to wait until the end. Okay, so now I have negative 4i being multiplied by just this next piece. Okay, so now we can just distribute. And in fact, I take it back. I'm going to change this right now because we don't want an I cubed in there. Okay, so we know that 4 and an I squared always turns to negative 1. So 4 times negative 1 turns into negative 4. Now let's go ahead and multiply it by the negative 7 plus 5i. Okay, well, when we multiply this out, just take negative 4, distribute it, meaning multiply it to both. We have negative 4 times negative 7, which is going to give us a positive 28. Negative 4 times positive 5i is going to give us negative 20i. Okay, I don't see any I squared, so we don't have to change anything. And it is in the proper order, so 28 minus 20i. And there we go. Okay, let's look at number 10. So again, we don't see two binomials here, so I'm just going to go ahead and distribute. I'm going to multiply these two terms first. So I have negative 3 times negative 2i. Okay, negative 3 times negative 2 is going to give me positive 6 and just the 1i. Okay, well now I can take 6i times 8 minus 7i. Okay, and I can just distribute those guys, take 6i, multiply it to both of those guys. So 6i times 8 is going to give me 48i. And then 6i times negative 7, 6 times 7, gotta remind myself, that's going to be negative 42, and since there are two i's being multiplied together, I squared. Okay, now remember that I squared always turns into negative 1. So now we have negative 42 times negative 1. Okay, well, negative 42 times negative 1 is going to give me positive 42. And then we always want our term with the I to come next. It's positive 48I, so plus 48I. And there's our final answer. Okay, beautiful. And let's look at 11. This guy is a little different. Okay, we see negative 3 minus 8I squared. Well, this can just be rewritten as negative 3 minus 8I times itself. Negative 3 minus 8I. Okay, now we have two binomials being multiplied together, so I actually can use FOIL on this guy. So let's remind ourselves what FOIL stands for. So I'll go over here where I have some room. So I have F-O-I-L. F stands for the first terms you multiply. O are the outside terms, the inside terms, and the last terms. Okay, so let's go ahead and do that. So we have F, so my first terms. So I have first times first, negative 3 times negative 3 gives me positive 9. Then I have my outside terms, negative 3 times negative 8I is going to be positive, 8 times 3 is 24, 24I. Okay, then I have my inside terms, negative 8I times negative 3 again. So another positive 24I. And then L stands for last. So last term times last term. Negative 8I times negative 8I is positive 64I squared. Okay, I can combine like terms, but before I do that, I see that I have a negative I squared, which turns into negative 1. Okay, well, negative 1 times positive 64 is negative 64. Okay, now I can just combine my like terms. Okay, so I have my constants. 9 minus 64 is going to give me a negative 55. And then 24I plus 24I, or 24 plus 24, positive 48I. And there's our complex number. Okay, let's do that one more time. So this guy, I see that we have two binomials, which means I could use FOIL or the box method. And since we haven't gone over it, let's just use the box method on this guy. Okay, so box method, draw yourself a box. I'm going to put my first term, or my first binomial on top, so 6 plus I, or 6 and I. And then my second binomial down the side, 3 plus 5I, or 3 and 5I. Okay, now I can go ahead and just multiply these guys out, box by box. So 6 times 3 in my first box gives me 18. 3 times I in my next box, 3I. 6 times 5I is going to give me 30I. And then 5I times 1I, 5I squared. Okay, now I can go ahead and just write these guys out in the same order I solved them. So I have 18 plus 3I plus 30I and plus 5I squared. Okay, well, I see my rule here. So I have an I squared, so that's going to turn into a negative 1, or 5 times negative 1. Okay, well, 5 times negative 1 turns into negative 5. And now I can just combine my like terms to get my final answer. So now I have 18 plus 3I plus 30I minus 5. So let's go ahead and do my constants first. 18 minus 5 gives me 13. 3I plus 30I is 33I. And there's my final answer, my complex number. Okay, those are your notes. There is an assignment that goes with it.